Um, Hi, this is Merlin. I'm just gonna talk about what I learned today. Um, so, so I also started the project. I'm implementing B3, and and that is kind of problem I faced, which is, um, I'm very kind of like new to making some kind of library for the B3, and first of all, I put all of the like logic in the B-tree class, the page class. So there's all a bunch of logic, and I found out that this is really hard to read. So, and I look at the other way to like what the other like big tech company did, and I just really doing same thing. So I put all of the like utils on the utils file, and if it's ties, I put the ties. But I think this one is kind of like good good code that I implement. So if it in the primitive file, I put the primitive page. So what why do I need to have why do I need to have like put the primitive page in the primitive? The reason why I make some kind of primitive is because there's something that doesn't change in the like data structure. Example, like the bit tree in the bit tree or those kind of indexing algorithm, and inside that there are some kind of page. So node is actually equals to the page. Like it's called a DB page, and this page, it could be different. Example, like there's another algorithm like BPA, so which is like B3 like page node layout, those kind of thing. But whatever. But I know there's like it's kind of very unexpected, so I really have to make it as a like page object into peer that I can extend or manipulate it. So bit primitive page is really stable that even though like the I change the B tree into B plus tree, this code will be stable. So I put as a primitive, and also I extend the status. I think this code is not very good because it doesn't get this object, but I'm just gonna make it like this because I have to implement it, but I don't know what to do, so I'm just gonna just do it like this. I think I think I had to implement more. So the reason why I make it status is, in the bit tree there's a formula. So each page's lift is also a formula, each page overflow is also a formula, and each page underflow is also a formula, and each index of primary key is also a formula. So those kind of thing is the bit tree or whatever tree, and I believe that this is kind of like really stable, that even though like there's a lot of technology change, this kind of formula won't change. But I think I have to like put it in the I have to refactor into B3 status. Another thing I learned was, if you look at this search part in here, the search part is really easy. There's only a little bit code, but this is recursion. So example, if I'm trying to do the insert thing, I have to first search if there's like target query key, and I have to insert it. But my question is this really enough good code or not? Putting all of the like logic into like search. So example, I wanna search. There's a target key on my current page, but since I cannot use this kind of search logic because this search logic is bunch of recursion that go to the left, so I cannot utilize it. So this is kind of how to say it. I don't know what to say in the OOP. It's like really like it's really chained. I cannot really take away. So I was like, okay, so why don't I make some kind of search key using iterator? So I look at this some kind of like design system iterator in this TypeScript, and I found out that there's kind of iterator class. So if you look at here, there's like, there's like iterator here, iterator class. Oh, I didn't. Wait, hold on a minute. Oh, okay, there. What? Yeah, but never mind. So there's a iterator class, and I extends it on the B3 iterator. I think I have to. Yeah, I have to extend it. So based on that, I extend it. So iterator is pure, so I can extend it in the B3. So if it's like other algorithm like B plus 3, I have to extend from the also iterator. So iterator is kind of pure, so I just have to extend it. So this B3 iterator is really nice. So there's an iterator node. So what this iterator node is doing is it's just holding a state for the iterator. Example, if you look at iterator class, iterator type, there's a position, index, last, and value. So I can create those kind of like iterator node via this binding. I got this code. I found this code similar in the Rick Fiber. So I think this is kind of good. The reason why I don't really prefer the class thing is that if this kind of values is kind of very smart for the class. Like if you look at make a class, you have to think about private and public, and you have to make it like those kind of things. But I feel like this is kind of really sugar syntax of it. So I'm just, yeah, it's really sugar syntax. But also if you look at if you're trying to compile with the B8, the function is also the faster than the class. So I just put in like this. So since so go back again. So iterator node can have some kind of like state of current position or what for the iteration. So for the current, I return the current index of it. But if it's like next, if it's not next, I call some kind of logic here. So this is already kind of search logic I made. So it's really different with the previous one. Previous one is just like recursion stuff until I found it. If it's not, return false. If it's if it's leave, return false. So that is thing I cannot control. But this one is I can control. So this search is for the current node, current page. If I found the index, okay, just reset in this index, and also reset and put into value of it, return this. But if this page is leave, okay, you have to put the true as the last. But if there's more of the child, if there's more child to traverse, you don't really you return the which index has to be traversed. So that means that I can utilize those kind of thing into even insertion and deletion. Example, if you're trying to insert, I can use this search logic iterator. And if I found it, put something. I don't have to like think about other code for find the next children. So I think the putting it like this is really kind of definite and really kind of nice, because it's really things I can control, and I can revise this code easily, unlike other one. Other ones like it's really change enough, and other code is this. Sorry, I didn't. Let's zoom it. So other code is this kind of page thing. Actually, I don't like this kind of class thing. I don't know. I mean, like, it's kind of okay, but it doesn't really looks good. This page overflows is there's no really kind of business logic in here. It's just the thing in the page core. And I also have to revise, have to rename the B3 page or whatever. Yes. So those kind of things. So an iterator node is I make it like this. So all of the logic is gonna put into B3. It's a class. So I think because the B3 the logic business logic is really kind of complex. So I prefer class if you look even in this perspective, but I think the most important thing I learned was to kind of like using passing this and putting like this. I think this way is very nicer than the V4. It's kind of seems like the React code. So I think this is it. I utilize the design system of the iterator and builder. And next thing is I have to do is when trying to using the index algorithm, I'm gonna use the design system of the strategy design system. So because there's a bunch of index algorithms, so I can compare to it. So I think this is it. So this is it. Have a nice day. See you next time. Bye bye.